Hello boys and girls, here we're looking at lesson 12-2 on page 398 of the math journal, and we are going to talk about probability. Here we have a wheel which we could spin, and if we were to spin this wheel, we want to see what are the probabilities of getting each number. Well, what are the probabilities? Let's say I were to put a spinner on this and I spun around. What would be the probability of landing on 1? Or landing on 6 or 8? Well, there are 10 numbers, and there's only 1 in tens. In all the 10, there's only 1 6 and there's only 1 8. So the chances would be 1 in 10 to land on any of those numbers, 1 in 10. Okay? But what if I asked you, as it's mentioned here, what are the chances that it will land on an even number? Again, an even number. We know that even numbers are 2, 4, 6, 8, 10. So half of the numbers are even. Okay? Each one will give me a 1 in 10 chance. You see, 1 in 10 that it'll land on 2, 1 in 10 that it'll land on 2, 1 in 10, 6, and so on. Okay? When I add all those chances up, I get 5 over 10, which is half. Half of the numbers here are even, so I have half the chances. The same applies to the odd numbers. Odd would be 1, 3, 5, 7, 9. Well, if I spin this around, there's a chance, half the chance that it will land on an odd number. Okay? So let's answer 1 to 7. Let's see. Find the spinner. The spinner lands on an odd number. Well, we said that half of them are odd, so what are the chances? Now, here's where you can write by writing it in many different ways. You can say there are 5 out of 10. Sorry, you know what? Let's change that to a darker color so you can see it better. Okay, let's pick black. There are 5 chances out of 10. We can simplify this and say it's half the chance, half the opportunities. Or better yet, give me a percent. There's a 50% chance. Okay, whenever we're talking about chance, it's always good to use percentages, boys and girls. You can also use fractions, okay, when you have a small fixed number or maximum, but most times people talk about percentages, such as there is a 10% chance it will rain. Let's say we eat pizza once a week. There is 1 in 7 chances that we will get pizza today, okay, because there are 7 days in a week, so there's 1 in 7. That would be fine for a fraction. But if you have an obvious percent, such as a quarter, 25%, 50, and so on, use percentages. Let's continue. The spinner lands on a number less than 7. Less than 7 would mean less than 7 from here this way. Okay, it does not include 7. So less than 7, what are your chances? 1, 2, 3, 4, 5, 6. So 6 and 10. The spinner lands, which 6 and 10 would be 60%. Okay? Let's continue. The spinner lands on a multiple of 3. Well, what numbers, when counting by 3s, what numbers will you hit? Well, 3, 6, 9. There are 3 of them. So 3 out of 10, 30%. The spinner lands on a number that is a factor of 12. Which numbers do I have to multiply together to get 12? I can multiply 2 and 6. Okay? Let's circle those. I can multiply 2 and 6. That gives me 12. 3 and 4 gives me 12. And that's it. I only have 4 of them. So 4 out of 10, which would be 4 to 10 is 40%. The spinner lands on the greatest common factor of 4 and 6. What is the greatest common factor of 4 and 6? Okay? When you multiply, when you look for the factors for each number, which one will be the greatest? And the spinner lands on a prime number. Let's identify our prime numbers. 1 is not a prime number. Do not make that mistake. 1 is not a prime number. 2 is 2, 3, 5, 7, and that's it. 1, 2, 3, 4. So 40%. And number 7, the spinner lands on a number that is not a prime number. Okay, what's left? What's not a prime number? Go ahead and identify that. Please, boys and girls, write the fraction and the percent for each one. Following the next page on 399, we are given a situation here where the school cafeteria offers these choices for lunch. For the main course, you can have chili or hamburgers. Ooh, I would definitely pick the chili. Love that stuff. For drink, milk or juice. Yeah, I'd probably pick the juice. Dessert, apple or cake. Nothing beats an apple for me. Okay, but you can mix and match. Rather than getting a chili, you can get hamburger and juice or hamburger and milk. You could also get chili, milk, and a cake. You have multiple different combinations that you could get here. Let's look at number 1. How many different ways, okay, right here, how many different ways can a student choose one main course, one drink, and one dessert? Use the multiplication counting principle. Okay, what they mean by the multiplication counting principle is that we're actually going to multiply all of these choices because that will give us the number of choices at the end, the ultimate number of choices. Well, I have 2 choices for the main course. So that one is going to be 2, right? I have chili and hamburger. For the ways to drink, I have milk or juice. That's another 2. And for dessert, I have apple or cake and another 2. When I multiply 2 times 2, I get 4. And then times 2, it's 8. The number of different combinations I could have is a total of 8. Yeah, I hope you understood that. You can always multiply the first set, 1, 2, the second set, 1, 2, and the third set, 1, 2. When you multiply them all together, it will give you the maximum amount of combinations. For number 2, we're going to draw a tree diagram to show all the possible ways to select foods. Okay, well, what they mean is main course. What do we have for the main course? Oh, they've told us that we had chili and hamburger. With each chili, I could either choose to have either drink. Okay, I could have milk or juice. And with the hamburgers, I could also have milk or juice. So those are my options so far. And then when we move over to dessert, with each one, I also get 2 more choices. Okay, I can either have the apple, okay, on one line, and then the other line the cake. Apple and cake, apple and cake, apple and cake. Go ahead and fill that out. And these are called tree diagrams to show all of your options. At the end, the chili with the milk and the apple could be a choice. The chili, the milk with the cake could be another choice. And so on. And it follows these patterns. Okay, so like the hamburger, the milk, and the apple. Or the hamburger, the milk, and the cake. And so on. The hamburger, the juice, and the cake. Those are all the options that you get. And when you see, you have 1, 2, 3, 4, 5, 6, 7, 8, as we mentioned above. Now, let's see here. Do you think that all the combinations of foods for lunch are equally likely? Well, equally likely. I want to say yes, but this is not like rolling a dice. It's not like flipping a coin. People tend to like either chili or hamburgers, okay? Or maybe they like both, but not everyone likes milk. Some people prefer juice, okay? Not everyone can eat cake. What if somebody chooses chili and juice? They might want cake, or chili, and the chili is spicy. They might want milk for the spice, and then they might want something sweet like a cake. Okay? Or some people can't have cake because they can't have eggs, so they might have an apple. So no, chances are not equally likely. More students might choose the cake over the apple. Some students might choose the juice over the milk. Okay? Now here for question 3B, here's our first key answer. Please write it exactly as I do. Explain your answer. The foods are probably not equally popular. If cake is more popular than apple, lunches that include cake will be selected more often.